In the world of particle physics, scientists have a name for things they can't explain. They call it noise, interference, a glitch in the matrix. But what happens when the glitch happens again and again? When the impossible seems to repeat itself? This is the story of a ghost in the machine and the hunt to prove it's real. Deep underground, in massive detectors that cost billions to build, scientists are probing the fundamental laws of our universe. They smash particles together at nearly the speed of light and sift through the debris, looking for something new, something that shouldn't be there. And recently, at one of these experiments, they saw it, not once but 4 times. 4 tiny, fleeting signals that have the physics community whispering with a mixture of excitement and deep, deep skepticism. To understand why this is such a big deal, you have to understand a fundamental problem in particle physics. You can't actually see the particles you're looking for. They are unimaginably small and exist for a fraction of a second. Instead, scientists have to rely on secondary information. It's like trying to identify a mysterious animal only by its footprints, or a person only by their shadow. You have to become a detective, piecing together clues to reconstruct what must have been there to create them. These clues can be the energy a particle deposits, the path it bends in a magnetic field, or the specific way it decays into other particles. But this data is often messy, fuzzy, and inconclusive. It's easy for a trick of the light to look like a monster. This is the heart of the mystery. A team of researchers, including physicist Kohsaku Tobioka, observed 4 events that shouldn't have happened. The signals were striking, but the first rule of science is to question everything, especially yourself. So, their first assumption is that it must be noise. But, as Tobioka explains, that explanation itself is hard to believe. In this case, the expectation of noise is very low. So even one event or observation is very striking. And in this case, there were 4. Think of it like this. If you're in a silent room and you hear one creak, you might dismiss it. But if you hear 4 distinct, identical creaks in a row, you start to believe there's someone or something else in the room with you. Tobioka says that for this kind of noise to occur randomly 4 times would itself be wild. So, what's the next step? The team must now do what all great scientists do, try to prove themselves wrong. They must definitively rule out noise. This is the less glamorous but absolutely critical part of the process. They will run endless simulations, checking and rechecking their instruments for any possible malfunction. They'll analyze every millisecond of data from around the time of the events, looking for any anomalous power surge, cosmic ray, or software bug that could have created a false signal. They're essentially trying to murder their own discovery, and only if it survives this trial by fire does it have a chance to be considered real. The reason scientists are so captivated is that if this signal is real, and that's a massive if, it could be the key to unlocking physics beyond our current understanding. Our best model of the universe, called the Standard Model, is brilliant but incomplete. It doesn't explain dark matter, dark energy, or gravity on a quantum scale. Discoveries like the Higgs boson filled in a missing piece of that model. But a signal like this wouldn't be filling in a missing piece. It would be finding a piece from a completely different puzzle, hinting at a whole new layer of reality we never knew existed. This is how science truly moves forward, not in a straight line, but in fits and starts. A strange bump in the data, a whispered, "That's odd," a relentless pursuit to understand whether the answer is a revolutionary new particle or just a ghost. For now, the phantom particles remain just that, phantoms. But the hunt is on. The experiments are running, and the world waits to see if we've finally caught a glimpse of the impossible, or if we've simply learned something new about the shadows our machines can cast.